Hello, and welcome to part 5 of Learn How to Program. My name is John, and today we are going to talk about logical operators. So here's an overview of the course so far. There's a video for each and every one of these. We've talked about what is programming, what are variables. We talked about if statements, booleans, and control flow. We've talked about functions and their role in programming. And then in the last video, we talked about for loops, creating lists, transforming lists, filtering lists, and today we are going to talk about logical operators. But what exactly are logical operators? Well, logical operators help us to combine statements that control the flow of a program. This is actually what they look like. So on the left-hand side, we have the name, and on the right-hand side, we have the operator. That's what you're actually going to be using when you type this out into a program. So the name of the first one is and then it's denoted by the operator ampersand twice. So ampersand, ampersand. The next one is or, and that's denoted by two pipes. And the last one that we are going to talk about is not, which can be expressed by using the exclamation point. But it's great that we know what they look like, but what are these operators actually for? Well, here I'm going to give you a really practical example. So the first one that I want to talk about is using and. So just imagine this. John really likes burgers. He saw that Burger Empire has a deal this week. You can get a burger and fries for $3.50 instead of the usual price of $5 for both of those items. I put an asterisk next to Burger Empire because I totally made that up and it is not real. And if it's a real restaurant, then that's just a coincidence. So here's a price breakdown. So this is before we as programmers implement the new deal, the deal of the week. So right now, as it stands, a burger is $3 and fries are $2. Since we are fantastic programmers, we are going to go ahead and implement it like this. Whenever you have a burger and fries, the price is going to be $3.50. Whenever you have a burger by itself, it's just going to be $3. And then if you just have fries by itself, it's just going to be $2. So pay really special attention to the first row, the row with the burger and fries. Burger, ampersand, ampersand, fries. So if we have a burger present, and if we also have fries present, we want the program to charge the person $3.50. If we only have a burger, $3, and if we only have fries, $2. So this seems actually really simple, but what we actually need to do is transform this into code, which we will do later on in the exercises section of this video. The next thing that we're going to talk about is using or. John also enjoys a good shake. This week, he has noticed that if he gets a mango or a vanilla shake, they will throw in a cookie for free. However, this only applies to these two flavors. That's really interesting. So let's take a look at the price breakdown again. So the first item is chocolate for $3. The second is vanilla for $3. Then as you can see, the last two have not been very popular lately because they're only 25 cents more expensive than the vanilla or the chocolate shake. So in order to incentivize people to go ahead and buy these, they're throwing in the extra cookie. This is the deal of the week. So this is a little bit different because last time, in order to execute a line of code or in order to get the deal, you had to get two things. This time, if you get the mango or the strawberry, then you get the extra cookie. That's kind of the key difference. With the and, both things have to be true. With the or, either one of those things has to be true. And we will clarify that and what that actually means later on in the exercises section. But basically, take a look at this table. Mango or strawberry, you get a cookie. If it's just chocolate, there's obviously no operator, and then there's no extra. If it's just vanilla, there's no operator, and there's no extra. Pretty simple. So the last thing that we're going to talk about is using not. So John has kind of overdone it. John's tummy kind of hurts. From now on, John will only go to Burger Empire if he's actually not full. So this is really important. This is a reminder of what we've talked about in earlier lessons. So if you remember, in our video about if statements and booleans, we learned that we only go down a path if the value is true. If a value is false, we can't execute the statement. So if you're creating an if statement, so if John is full, you are only going to execute the code after that if statement if that is actually evaluated to true. So if John is not full, then you are not going to execute that code. So let's take a look at what that looks like on the next slide. So here we have two decision trees. So on the left is how we've been doing it traditionally, and on the right is how we're going to do it today. So on the left, you can see the tree where you have full without the exclamation point. If it is true that we are full, then we don't go. If it is false that we are full, then we go, meaning that we're hungry. The one on the right is actually the exact same thing, except that we've kind of flipped it a little bit. So what I mean by that is we put an exclamation point in front of the full. And so now how this works and how you read this actually is, let's say the value of full is true. So John is full. What that exclamation point does is it flips it. So instead of it being true now, it's false. And if we follow and see where we go when it's false, as you can see, we don't go. But now let's say the value that comes into here is actually false. Well, the opposite of false is true. So now we go. So it's actually just a different way of formulating the exact same thing that we see over here. This is something that we use a lot in programming, actually. Negation is something that we use all of the time. So this is actually the exact same thing as the slide before, but now we are taking a look at this as a table instead of as a decision tree. So don't get too caught up in this. If this is kind of confusing, don't worry about it. We are going to go into some exercises in the very next slide. So let's say the value that comes in, so now I'm looking at the very first row. The value that comes in is true. If we negate it, then that value is false. And the result is don't go. So if you read this out in English, what this is actually saying is, if John is full, then we do not want to go. The next one is similar, but instead of starting out with a true value, we're starting out with a false value. So now I'm looking at the second row. If it is false that John is full, we negate that using the not. Then that becomes true, and the result is go. Today, we're going to do something new. We've been coding so far using the Kotlin playground, which is all fine, but it's time for us to upgrade our setup a little bit. And there's a few reasons for doing that. One, the Kotlin playground doesn't always work for everybody, but if you get the IntelliJ stuff set up, it will for sure work for you. And you're going to have just less issues in general. It's also something that we as professional programmers use. We're actually going to download the IntelliJ Community Edition. So if you don't know yet, IntelliJ is a program that helps you to write programs. So what it does is it's kind of like a glorified text editor that tells you like, oh, look at this, your code is wrong, or this isn't compiling, or this isn't working. And it kind of guides you. It also does like autofill. So like if you want to finish like a method name and stuff like that, it will do that for you. So it will populate the name before you can even finish typing out the name of a method or a function. It's just all around a great tool. Professional programmers use it all the time. So I'm actually going to walk you through how you actually go about this. So the first step that you need to do is you need to go to the YouTube video. The YouTube video is in the description, and I also put it in the slides right here. Watch this video and then come back right here to the slides, and then we'll keep going. So now let's get to coding. So the link is in the video notes. Alternatively, you can just type it in. So I've already typed it in or clicked on the video notes, whatever. And what we need to do is to go to that link, and then you arrive right here. So as you can see, actually what I did is I made a bit.ly link right here for you guys. So if you wanted to, you could do this the quote unquote old school way that we have been doing it, where you can just use the Kotlin playground, which is totally fine. But I just know that it's kind of buggy sometimes, and it's very browser dependent, and yeah, it just doesn't work perfectly all the time. So what I would prefer for you guys to do is after you watch this YouTube video, that means you'll have IntelliJ Community Edition set up. Then what you're going to do is you're just going to copy and paste everything from fun main all the way down here. Then you're going to open up your IntelliJ IDE. If you've gone through the tutorial, your stuff should look something like this. Then what you can do is just right click. So what I did is I clicked on this and then right click and then new and then Kotlin file or class. And we're going to call this blank exercises part 5.kt. And now all you have to do is copy and paste this in here. And then if you hit start right here, it will actually run the program for you, which would be fantastic. So it's got to compile some stuff, getting it all ready. Look at that. So this is exactly the same output that you would get if you ran this in the browser, but now we're actually using an IDE, an integrated development environment. So like I said before, it's a glorified text editor. And this is a lot more reliable. This is what the pros use. This is actually the community edition, which is for free. And if you get really seriously into programming, you could even upgrade to the pro edition. So now let's get started with the exercises. So all of these exercises are actually the same examples that we just went through in the slides. So there's going to be an exercise with anding, with and, an exercise with oring, and there's going to be an exercise with negating a statement. So the first one that we're going to talk about, actually what this is kind of like an ordering service. So at the very end, we're going to calculate your order. That's part of the bonus right here, your order total. And it will tell you exactly how much money you owe to Burger Empire. But we are going to split this up into different phases. So phase 1 is getting the burger and fries order. Phase 2 is getting your shake order. And then phase 3 is making sure that John doesn't go back to Burger Empire unless he's not full. So unless he's hungry. So for the first one, Burger Empire always likes to start with your burger and fries. Calculate the price of John's current burger and fries order. So what's really important to know about this, actually, is that you are only allowed to get one burger and one order of fries. So what that means is if I were to, for example, have burger, 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 burger on here, they are only going to make one burger for me. So that's a really important point. That's just the way that we designed it. Obviously, we're programmers. We can make it whichever way we want to make it or however we want to make it. But in this case, what we're going to focus on is this right here. So if a customer orders a burger and fries, charge them $3.50. Otherwise, the burger is $3 and the fries are $2. Return the total value of this part of the order as a double. Assume that you cannot buy more than one burger and one fry. So a double is this. So remember, that's an integer followed by 2 decimal points. And then what we're actually going to do, let's kind of outline this. So if order items contains burger and fries, then $3.50. So let's just copy and paste this because I don't want to waste my time or your time. If order items contains just burger, contains a burger, then 3. And then if it just contains fries, let's just copy this right here, delete a bunch of extra space, then $2. So how would we actually go about this? All right, well, one thing that you can do is you can grab order items. So let's just see if we can actually, I'm going to do this down here actually. So let's see if we can transform this into code. It's actually a lot simpler than you probably imagine. So if order items, right, because that is all of the items in our order. If order items contains burger, let's just for now do it this way. Then return 3. Right, so this is actually not going to It's not going to be the exact solution of what we want, but the thing with programming is that you have to do things in small steps and then build on those small steps. So what this is going to do is it's going to look through our order, which is burger, fries, ketchup, and raccoon. Currently, what it sees is, hey, I do contain a burger, and then I return $3, right? That's not exactly what we wanted, but it is a step in the right direction. So in this case now, let's say that we wanted to do the special. Well, then what we need is and. But in programming, that is just ampersand, ampersand. Then what you do is order items dot contains, excellent, and then fries. Look at that. But now the price is wrong, so it should be $3.50. So if we redo this, what you're going to see is the price is now $3.50. Look at that. Super good job. So we do have a burger and an order of fries. Therefore, it says right here, charge them $3.50. All right, but let's say that they do not have an order of fries and a burger, right? Let's say we just had a burger. Well, right now, this is actually not going to work because this only goes into this part right here. It only returns if both of these are true. If both of these are not true, it's just going to return 0. So let's just confirm that before we keep going on. So let's just change this to bubblegum and then redo it. So now this part is no longer true. The order items does not contain a burger and fries. It contains no burger and just fries. So both of these things have to be true in order to get here. So now what we need to do also is we need to handle the case where just one of these things is true. Meaning we have a burger or we have fries, but we do not have both. So what that looks like is, let's just type in burger right here. And as we know, if we just have a burger, so how this works is this evaluates to, hey, I don't have both of those things. And then this gets evaluated and it finds out, hey, but I do have a burger. I don't have a burger and fries, but I do have a burger. And then this returns 3. So let's just verify and make sure that that all works as intended. So let's just have one burger here. And let's rerun this. And excellent, so 3. But now let's say that I only have fries. So you kind of guessed it, because we do not have a case for just the fries. We have a case for burger and fries, and we have a case for burger, but not for fries. So what do you expect to happen here? Not true, return 0. So let's just verify that. It's always a great idea to verify your stuff step by step. Look, 0. So now let's do the case where else if order items dot contains, and let's type in fries. And now return, and it said 2 in the instructions. So now if we redo this, this should have covered all of our cases, which is awesome. So let's change this now to burger and fries, and let's rerun our program. As you can see here, $3.50. By the way, I have been rerunning it using a shortcut. If you go to your play button right here, it will tell you which shortcut you need to use in order to hit play. So you can either go right here and hit run, or in my case, for example, it's Control-Shift-R. Yeah, just a small little tidbit. Okay, so burger and fries, $3.50. That's excellent. But let's say I just have a burger. So this should just be 3 now. Yep. And let's say that I just have fries, which is kind of weird. I do love fries though. 2, great. And now let's say burger and fries, and this should be $3.50. And like we said before, if you have multiple burgers, the price is not going to change because we only allow you to get one burger and one fry. So if I have burger, fries, it's still just going to be $3.50 because it's just looking to see, is there one burger? Is there one order of fries? And then it's $3.50. It's not looking to see if there's several of them. And if there are several of them, how many? That would be more complicated. What we wanted to just do in this example is to work on andings. And that's exactly what we did here. Okay, excellent. Super good job. So now let's move on to exercise 2. So in exercise 2, this is a little bit different. So yes, we're going to be using logical operators like in exercise 1, but the difference is here we're going to be using ORs. So if it's a mango shake or a strawberry shake, we want it to go into a certain path. So both of these things do not have to be true in order for us to go down the path. And what I mean by go down the path is, for example, this right here. So in this example, this has to be true and this has to be true. And then you go down this path. But in the next one, if either one of these things are true, it goes down the path. Another interesting thing just that I wanted to point out here is that in this exercise, it is possible to get several shakes. So you could, for example, let's say that I have something like this. Okay, so you can actually fill this with mango, and then what this will do is this will add the price of the mango, add the price of the other mango, add the price of the chocolate. Jelly is 0 because that's not real and stupid. And so it will add all of these prices together. And then if you get one mango shake, one or more, then you are entitled to a free cookie. But if I get 4 mango shakes, I still only get 1 cookie. So that's a really important thing just to note. So what we're going to return here, actually, let's take a look at this, is a pair. So the first part of this pair is going to be the sum of all of the shakes that you bought. So you can buy multiple shakes. And then whether or not you are entitled to a cookie, which will be denoted by Boolean. So true means, hey, give me a cookie. False means, hey, no cookie for you. Okay? So let's just dig in right away. So what I love to do is I love to break down problems into really small, just like really small portions. So what I mean by that is, let's just pretend like this order items doesn't exist, right? And let's just say that we have 1 shake. And let's just say that the flavor of the shake is mango. So according to this right here, if they order a mango or a strawberry shake, it costs $3.25 and they get a cookie. All right. So let's see if we can go ahead and implement that already, just for the mango one. So if shake equals mango, okay, then we are going to return, lowercase John, return a pair where the first one is the price, so $3.25 is a double, and the second part is cookie. We know that they are entitled to a cookie. So again, this has not touched any of the list items. We just want to see, okay, can we solve this for one item? Then once you've solved it for one item, you can apply it to all of the items, and we will go over what that actually means in a second. Awesome. So now let's say that this is actually, instead of mango, that this is strawberry. So this is one tactic that you can use until you get good enough where you can kind of do this all kind of in your head. But even and I'm a professional programmer, I love breaking down things into really small bits and pieces and then building and building and building. So as you can see right here, the value of this is 0 and false because we haven't done anything about the strawberry case. So if the shake is equal to mango or the shake is equal to strawberry, whoa, I'm going to do this uppercase. I think there's a shortcut for that. Strawberry. Okay, great. Then this is going to return a pair, right? So this is not taking care of the case where you have 4 mango shakes or 4 strawberry shakes, but we will get to that later, I promise. So just replay this, and then boom, it's $3.25, and it's true. All right, but now let's say that the shake is chocolate. So I'm just covering every single one of the options here. So it says if they order a chocolate or vanilla shake, that costs 3, but they don't get a cookie, right? In this case, return false as the second value of the pair. So this is actually, funnily enough, this is the second time where we get to use or, because the chocolate or the vanilla returns 3 and false. So if the shake is chocolate, or the shake is vanilla, then we want to return a pair where the first value is 3 and the second is false. Right, so now we are never going to go right here. It's going to hit this return and then return the value immediately. So notice what I love about IntelliJ is that it just tells you great things. So right here, this is grayed out, meaning that order items is not being used. But what you will notice is this order items is white, meaning it is being used in here. So we still have not used the actual order items, these guys that are inserted inside of our function. Okay, looking good so far. Yeah, and this is fantastic. So let's also take care of the else case. So else return, let's just copy and paste this right here because this is exactly what we want. Great. But now here's the deal. We need to be able to order several shakes. All right, so how do we do that? Well, what I would suggest to do, let's not worry at all about the true or false part regarding the cookies, right? So let's just think about the price. What we want to do is for every single order item, we want to transform that. So think about that keyword, transform, this list into a list of prices. Once we have a list of prices, then what we can do is we can sum up that list with a really neat trick. So how do we do that? Well, if you remember from our previous videos, transforming a list is using map, okay? So the next thing that we can do is we need to use an individual item in that list, which would be this guy right here. You could also rename it to shake if you wanted to, but let's just call it. Okay, so now we're going to move this beautiful code that we wrote, put it in here. So this is still actually not quite what we want, because at the very end, we don't want to return this right here quite yet. We want to return something at the end with that something that I just told you about. So let's not worry about that, but let's just write return false right here. Okay. So we want to apply this for every single item. And so instead of returning, we just want to store this into a variable. So I'll say that again. Instead of returning right away, which only worked for one item, we want to store the price of that item in a variable, which is a list of doubles, and then sum up all of those prices. So let me show you what that looks like. You can do val prices equals, okay. We do not want to return. All we want is to transform this into a price, which is super simple. You just do this right here. Just get rid of the pair. All right. Excellent. And now actually what I'm going to do is I'm going to show you guys that this actually works. So I'm just going to do prices or println prices. All right. Excellent. So now when I print this out, it's going to say 3, 3, 3, 3. Okay, so let's actually take a look and see if that's true. So it says that there's 1, 2, 3, 4. So mango, mango, chocolate, jelly. That's actually incorrect. So why is that incorrect? Oh, it's because what we're saying right here is, yes, we're looping through the items, but this shake still points to this. It should be pointing to this. See how this is grayed out? So if we just switch this, then we will see what we want. And it's always a good idea to think about, what do you think is going to be the output? So I think it's going to be mango 325, 325, 3, and 0. So this should be 325, 325, 3, and 0. So let's just run this puppy. 325, 325, 3, and 0. Excellent. But we want this guy right here in the end not to return 0, but to return the sum of these prices, which is super simple. You just do prices, and then you do this neat trick where you can just do sum. And so now, if we rerun this, boom shakalaka, 950, which is 325 plus 325 plus 3, which equals 950. Good job. As you'll notice, though, the cookie thing that we set is always false, which is not what we want. But there's a really neat trick for this. So actually, there's really fancy ways of doing this. But what we are going to do is actually to set a flag. And what this flag does is it keeps track of whether or not we owe a customer a cookie. So let's just do has earned cookie. And let's make this false. Okay, excellent. All right, so I made this actually mutable. Why did I make this mutable? Because if it's true that they ordered a mango or a strawberry, I want to be able to change this value. Usually we never do this. We just do val false, but then I wouldn't be able to actually change this value. So watch what I do right now. Has earned cookie. And then let's just set this to true. It's going to say, hey, what are you doing, buddy? This should be a var, right? You cannot change this variable. That's why this is mutable. So now I can change it. So if it's mango or strawberry, they are entitled to a cookie. And so instead of this being false, it's just equal to our flag. And now we run this. Boom. Now 99. And now, boom, 9.5 and then true. So just to prove to you that this works, let's say that we do not have any mango in here. Let's just make this chocolate again. So the price should be 6 with no cookie. Let's rerun this. Like before, 6 and false. Really good job. So the next part that we want to tackle is actually this negating. So this is actually going to be a lot simpler than you think. So basically, if John is full, so let's create a variable called is John full. And let's just default it to true. So is John full? Then go through our program. So this should have a closing thing. That's why this is complaining, right? So if John is full, then go into here, right? That's not actually what we want in the end. We want to only go if John is not full, okay? But let's just run it like it is right now. The whole program should run like before. Okay, great. But basically what we want to do is we want to create a condition such that this evaluates to true and goes in here. So what we can do is we can, let's just say that this is false. So now what this is saying is, hey, John is not full. Okay, so John can now go to Burger King or Burger Empire. Oops, sorry, I meant Burger Empire. Anyways, John, our most loyal customer, has an addiction to Burger Empire, and he wants to start being more responsible with his food choices. You, as the programmer, should prevent John from making any purchases if he is already full. But how do you do this? Well, this is what I'm teaching you right now. So is John full is false. So if we rerun this, what you're going to notice is nothing happens. That's because we need this guy right here to evaluate to true in order to go into here. So right now it reads if false, so it doesn't go in here. But we want it to read if true. That way it goes in here. If you negate this, then what this does is if is John full, which is false, then it flips it to true. So it reads if true, and then it actually goes in here. So if I rerun this, there you go. Our program ran. And now let's just make this true. And then there you go again. So now this is different. So is John full is true, but we do not want to go in here if that's the case. So if, and then true, So if true, flip it. So that means if false, it does not go in here. So if that didn't make a whole lot of sense to you, just like rewind, try it a couple more times, see if that will make more sense. And you're always, as always, you are free to ask me as many questions as you want in the comments section. So here's a bonus. Add up how much John's order cost and print it to the screen. All right, that's actually going to be pretty simple. So what we are going to do is, instead of printing these guys out, we are going to store these guys into variables. You've done this many times before. I'm using a shortcut to do this. So burger and fries order. So what I did on my Mac is command, if you highlight this guy right here, if you do command option and then V, then what that will do is that will actually create a variable for you. You can also just type it out. I'm not quite sure what the shortcut would be on Windows machines. You'll have to just Google that yourself. Okay, so now let's call this shake order. So now we have one variable with the price of the burger and fries, and then one variable with the price of all of the shakes. Let's change this actually to mango, just because. And then mango. And then let's get rid of these print lines. You don't need them anymore. And now what we are going to do is just print line. And then let's do burger and fries order plus shake order. What you're going to see is this doesn't work. Why does this not work? Well, the thing is, this guy is of type double, but this guy is of type pair of double and Boolean. So if you remember, we've talked about pairs before. You can actually extract the double from here by just clicking on first. First corresponds to the first type right here. So it corresponds to this double. If I were to type in second, this would be a Boolean, and it would not work because you would be saying a number plus a Boolean. Doesn't make any sense. So if we just change this to first, this corresponds to the shake order. And if you rerun this, it will tell you exactly, okay, let's just change this to false, meaning John is not full. So we are allowed to order from Burger Empire, and boom, the total of your order is 13. Really, really good job, guys. Really good job. Those were not easy exercises. I'm very proud of you. So now, to kind of wrap up the day, we are going to summarize what we've talked about today. So logical operators help us to combine statements that control the flow of a program. Anding two statements means that you will only follow that path if both things are true. So, for example, getting a burger and fries is only $3.50. Oring two statements means that you will only follow that path if one of the two is true. So, for example, you get a free cookie with mango or strawberry shake. And then finally, we talked about negating or nodding. Actually, nobody says nodding. I'm pretty sure they always say negating a statement, but whatever. So nodding a statement means that you will only follow this path if the input is false. So you will only go if John is not full.